Hi everyone, just a run through of our last workshop from last week. Here we go. We were looking at a mixed within and between and over. It means we've got at least two independent variables, one of which is between subjects, either within subjects, and we have a continuous dependent variable. In our data set last week, our between measure was whether or not they'd had some kind of a treatment, which we'd made up based on a published paper by these chaps, Fan, and the participant's task was to respond to whether a central arrow pointed left or right, and the dependent measure was the reaction time for this. This is the kind of displays we had, and there was a number of different types of cue, no cue at all, or a center cue, a little star appeared, or stars could be both sides, and so on. And in the middle of the screen, the task would be to identify the direction of the arrows, okay, and the flankers, these are the things surrounding the target in the middle, could either be uninformative, okay, or congruent with the direction of the target, or incongruent, pointing in the opposite direction, okay, and these influence the reaction time to responding to the arrow. And so our analysis then was the between subjects variable, was the group they were in, whether they received this fictitious controller treatment that was thought to influence their attention. The independent subjects variable is the cue type and the flanker type, of which had different levels, and the dependent variable is the reaction time. That was all in the data set that was communicated to you in the compendium. And the first thing we've got to know is whether we can use parametric stats, and this Morsley's test is testing this idea of sphericity. That's whether or not all of these different variables and levels can be regarded as coming from a parametric distribution, a normal distribution. And in this case, it's a bit like the Levene's test. If it's not significant, that means it's okay. And so for all of these different combinations of main effects and interactions, we can see that the probabilities are all quite high. None of them have got stars in this column, so that means that there's no significant effect, so no change from it being parametric. Okay, if it had been, we'd have had to use one of the corrected tests, the Greenhouse-Geiser one, for instance. So the analysis is performed as repeated measures ANOVA, and this allows us to pull out both significant main effects for the group, the cue and the flanker separately, and their interactions. And this table sort of summarises the kind of things you see. You see a set of the different levels of the model, tells you the degrees of freedom and so on. And the important bit, of course, is whether or not these separate components of our model are significant or not. And most of them are. Okay. Looking at the between effects, this is plotted out separately. We see that there's an overall effect of the treatment to speed up people's reaction times, only slightly, but it turns out to be very significant. And then in terms of the within subjects effect, this plot is showing so-called interaction plot, and it's trying to give you an impression of how all of these different variables are changing together. There's 12 different groups in the sense. So there's a group of responses which are congruent for a particular spatial cue. Okay, so we get 3 levels of flanker times 4 levels of cue gives us our 12 different means. And for each of those, we've got a different reaction time, okay, which we're measuring. So the main effect is that when there's no cue, which is the blue one, we can see all the times are the slowest, right? And in terms of the spatial cueing, the flanker things, the reaction time is significantly faster than for all of the other cues. That's this one here, the spatial cue. Okay. Interpreting the output then, so that's the between effects that we saw the graph for, and we've got the plot now of all of the individual means, okay, and in this case we're looking at analysis in terms of Fisher's least significant difference. This is allowing you to compare pairs of means, so the strategy is that having shown that the analysis variance has got some kind of effect in it, you can then compare the individual values to find out where the largest effects are, or the effects of interest to you in your particular study. Strictly, you can go directly to this stage. If all you want to do is compare particular means, you can do this without doing your ANOVA, but the usual practice is to do the ANOVA as well. Okay. The analysis proceeds by coming up with a value computed by the computer, and it tells you that if you compare any of the means in these two in this panel here, then if the difference between the means is greater than this, then that corresponds to it being a significantly large enough difference in the means. So for instance, this difference between these two is 467 minus 370 something or other, so that's 90, which is much larger than this. Okay, so this would be a significant difference. So in terms of the flankers then, so there's no different in reaction time for the congruent and neutral flankers. Okay. And the incongruent flankers, the ones in the middle, have got significantly slower reaction times. That means higher numbers. Okay, so for all of these, if you've got an incongruent flanker, you're going to be slower regardless of anything else. And then there's also observable an interaction. If you would compare the means of these two, okay, either the centre or double one, compare it to the case when the incongruent flanker is present, the difference there is about 100, about 99 or 100. Whereas if you compare these two, the difference is not quite so large, it's more like 70. So depending on whether you've got an uninformative spatial cue, the centre and double ones didn't tell you much, or an informative one, okay, it has a larger or smaller effect on your reaction time. So this so-called interaction, a dependency between those two factors. Okay. And you can calculate those differences here. So for instance, if you look at the congruent centre versus the incongruent centre, okay, that's where your difference of 90 odd is, and then you find the other two there, which were the congruent and no Q and incongruent no Q, and that gives you the value of difference of 70. Here's an example of rather poor reporting the results. They're giving some expression to what they can see in the tables, but failing to mention the details of what's happened. So you need to report them in the same manner as the other ANOVAs. You know, give the F values, the degrees of freedom, standard deviations, and so on. And those details are just as important as the P values. Okay. Something like this. You've got to state what you've done, mixed between ANOVA was carried out, and that there was a significant effect between the control, which has got this mean with a standard deviation and a treatment group, and so on, and the reaction times were significantly faster in these conditions. Okay. Furthermore, there was a significant main effect for the Q type, and so on, giving the F values, and for the similar ones for the flanker type. And then you go on to say what you did next. After looking at the ANOVA results, we looked at the results of the Fisher's least significant difference test, where you can look at the differences between mean values to identify the larger or smaller differences. Here's some peer reviews which were conducted on this. This person has commented that there's been a poor use of the graphics, which is good. You've got to make sure that you include those things, and that care wasn't taken to explain the output from the ANOVA properly, and then goes on to give what the solution was. All of the effects were significant apart from the interaction effects of the group and so on, group Q, and identified that the author didn't report it correctly. Furthermore, the author's not looked at the effects that the Q's have in the reaction times either, which they could have done. So that's a good example. And for question B, again, the authors correctly identified the two within subject's variable. That means they've reported what they've done accurately, and identified the two between subject's variable, but again, they've identified that there's poor use of the graphics, and how further explanation could have been made, commenting on when the spatial cues were provided, the reaction time was faster. It's quite complicated to describe all this, so one strategy would be to look at the way the fan paper communicated their effects, okay, to give you some clue as to how best to report it in your own work. Okay, thanks very much.